Welcome. We're going to speak about the stowage factor and we make a small introduction to the preliminary stowage plan. Thank you for being here. It's mentioned in Dutch. Uh, Something to keep in mind. In some weeks, in about 8 weeks, there's going to be one exam about this subject combined with stability. For this exam, you need to be in the position of a non-graphical calculator. It's actually allowed to have a graphical calculator if it's outfitted with the exam button, so you cannot use your memory inside. Just be aware of it. So we're gonna have a small glimpse at what we're doing at these two subjects, beladen, cargo handling, and ship stabiliteit. We're gonna look to this part in this timeline. It is usually work for the chief officer. Nevertheless, all the other officers, they are also having watch-keeping duties while the ship is in port. But the chief officer is usually responsible for making the ship and the cargo hold cargo-worthy and seaworthy as well. The ship needs to be seaworthy at departure, so the hatches needs to be closed and the cargo hold needs to be watertight. And during the voyage, the ship needs to remain cargo-worthy and remain seaworthy. So some definitions. We've spoken about seaworthiness during ship knowledge earlier this year. Just have a small glimpse at the two I'm having put up over here. They're a little bit holistic. You can add items to this definition to some extent. And cargo-worthy is a bit more easy to grasp. If you don't get a hold of this kind of definitions, use the pause button and please rewind. Cargo worthiness, the ship owner is responsible for cargo from the moment the cargo is loaded till the moment the cargo is discharged. So the person or company or party who is shipping something, they expect the cargo to arrive in the discharge port in the same way or form or with the same quality as it was loaded earlier on in the loading port. So that's the responsibility of the ship, the master and the owner. They need to make sure that the cargo is in the same condition when discharged. And that's always compared to as how it was loaded earlier on in the loading port. You're legally entitled as a ship master or owner to make sure that it's done. If you don't do it well, because you don't keep the cargo hold cargo worthy during the voyage, maybe the cargo gets wet and then the owner of the ship is liable. So you're legally forced to compensate the damage on the cargo. Yeah. So the shipper and the carrier, they agree upon conditions in a certain contract. This contract in shipping we usually call a charter. The contract is signed by two parties, and when it's signed, it has legal consequences, and this consists of rights and obligations of both parties. I think maybe this is a bit hazy, but bear in mind, maybe your father one day will rent a small minivan to move a friend with his furniture. Your father has certain expectations about the van, and the rental company has certain expectations about your father, how they are driving, in which state the van will be returned in the afternoon. And basically in shipping, that's not really different. It's all about managing expectations and uphold your word. And this word is written down with letters in a contract. Um, yeah, this speaks for itself. To do all this in a decent way, in a good way, and in a safe way, we need practical skills and knowledge, and it's all a big um, combination of practical seamanship, ship stability, ship's knowledge, and a little bit law. And to be more specific, it's contract law. We're going to do a little bit in year one and a bit more in year two, and we slowly make it a bit more difficult. An important factor to use when calculating if a certain amount, which is requested for shipping, you need to make sure by calculation if it actually fits in a ship's cargo hold. To do this calculation, we use the factor Stowage Factor. And it's a factor indicating how much cubic meters 1 ton of cargo contains. So how much space does it actually take? And with this factor, it's possible to calculate if a certain amount of weight will fit in a certain space or volume. So here you see some gaps between the three containers. This is maybe not a very economical way to ship, but as you maybe can see, a fourth container is not possible to put there. But to make certain calculations, if something fits, we need a stowage factor, but sometimes we have air gaps. I will speak about it a bit later. But the stowage factor, why so important? The amount of cargo hold space is limited, and with this factor we can easily calculate if an amount of cargo fits or not. And if it doesn't fit, it's not shippable by that ship. Something to be aware of, especially if you need to sign a contract, a charter with a party, you need to safeguard that you are able to ship the amount of cargo. And we do that with the stowage factor. So I make a typo over here for all you Dutch people watching this. In Dutch, we are prone to use the abbreviation SG, soortelijk gewicht. In English, I use specific weight over here. But stowage factor is the inverse of specific weight or soortelijk gewicht. So that means the units are also reversed. So that's why we speak about cubic meters per ton. And that's where we work from. So broken stowage, I just showed you the three containers. We sometimes have air gaps, and that's not a really economical way to ship things, but sometimes it's unavoidable. And in the case of the newsprint paper rolls, it's because of the shape of the cargo, not the size, but the shape of the cargo. It's round, so we have gaps remaining. You see them in orange yellow over here. And yeah, it's unavoidable, but in a way also a bit uneconomical to ship like this, but it's unavoidable. Sometimes we need to use dunnage, it's wood, to fixate cargo. Sometimes we use lashings, and this dunnage or lashings, they take volume or they take place, position, and in that places we cannot put any cargo instead. I will just show you in a second what is dunnage, and then you understand why it causes broken stowage. That's over here. So here we have some void filling dunnage. We're looking at a bulk carrier. You see the lower hopper tanks, and because of this, oh, I'm looking for my mouse. Where is my mouse? My mouse is here. Because of this steel profiles, they make squared bundles of it, and we still have this triangular space remaining where we cannot easily put any cargo. So they fill up the void with wood. Lumberjackers or timmerlui, sorry, die komen aan boord om dit te betimmeren. En zodoende wordt er over de breedte van het schip kunnen we de stalen lading fixeren. Sorry for my Dutch. Because of this void filling dunnage, we make a nice block stowage, and it's also a way of lashing these steel profiles by using this void filling dunnage. Same as for the upright dunnage, it's used to fill up this these spaces which are not used for cargo. It's also a way of void filling, and they keep the bundles separated. And another one is quite important, and that is here you see the wooden beams on the tank top, and they are aligned with the stiffenings in the bulk carriers double bottom tanks. So this is aligned with each other. So if we load cargo which is relatively heavy, we need to load on top of the frames, and by using dunnage, we can make an alignment between the stiffenings and the cargo pressure. So the pressure is transported actually by these wooden beams to the stiffenings in the double bottoms. Yeah, we're gonna watch a small clip later on after this one. I hope it will be a bit more clear then for you. A little bit about dunnage before we show this small movie afterwards. Cargo needs to be protected against damage while being stowed and while doing the sea voyage. It starts moving and it needs to remain in its place, and it needs to stay in the same form and shape and conditions, because that's where we signed for, and that's what's expected by the shipper of the cargo when the cargo arrives. It needs to be in the same state again. And we use dunnage for this. As you just saw, we use dunnage to fixate cargo in a certain position and to keep it there to prevent damage of the ship. This dunnage we just used is also to make sure that, for example, the side shell is not perforated or a ballast tank doesn't get punctured, and that's why we also use dunnage. Another one is to keep the bilge wells accessible to fluids. So we need to lift up the cargo a bit up from the tank top so that fluids, when the ship has a bit of trim, flows to the bilge wells. And that also has something to do with ventilation, where we speak about in the second year. So the Dutch word for dunnage is garneringsmateriaal of garnering. That's it. Thank you for watching.